This is AP Calculus AB. We are looking at L'Hopital's rule AP style questions. So here we got a multiple choice. Let's first figure out, does L'Hopital's rule apply? Maybe it does, maybe it doesn't. If we were to put 0 in here to the top, we would get, let's see, e to the 0 would be 1. Cosine of 0 is 1. And then 2 times 0 is 0. This would end up being 0. If we were to put it into the bottom, we would get 0 squared minus 2 times 0. We would also get 0. So this is going to produce the indeterminate form 0 over 0. So we can apply L'Hopital's rule, which means we can take a new limit by taking the derivative of the top and the bottom. The denominator's derivative is going to be 2x minus 2. That's pretty simple. The top, the derivative of e to the x is e to the x. The derivative of cosine is negative sine, so we have a negative sign is a plus sign of x. Derivative of a minus 2x is a minus 2. Let's see what this would be. If we put 0 into the bottom, we would get 0 minus 2, which is negative 2. If we put it into the top, we would get e to the 0 is 1. Sine of 0 is 0. And then minus 2 from that, we would get negative 1 over negative 2, which would be positive 1/2. That's answer C. Let's check out this one here. This one's going to infinity. This is our first infinity one. Let's see how this works. The bottom, if we put infinity in, it's going to go to infinity. The top, e to the 3 infinity is going to go to infinity, plus another infinity is going to be infinity. Natural log of infinity is going to go to infinity. This is going to produce the indeterminate form infinity over infinity. So let's try to apply L'Hopital's rule. So this should be equal to the limit as x approaches infinity. Take the derivative of the top and the bottom. The bottom's easy. The derivative of x is 1. Derivative natural log of something is the derivative of the argument over the original argument. So the original argument, is going to be e to the 3x plus x. The derivative of this argument is going to be e to the 3x times the derivative of this, so that's going to be 3e to the 3x, and the derivative of x is 1. This, of course, is going to be equivalent since we're dividing this by 1 to just this here. And that is the indeterminate form, infinity over infinity. So we got to do this again. This is fun. The derivative of the top, derivative of 1 is going to be 0. Derivative of 3e to the 3x is going to be 9e to the 3x. Derivative here on the bottom, e to the 3x derivative is going to be 3e to the 3x, and then derivative of x is going to be 1. If we put infinity in here to the top, it's going to go to infinity. Put infinity here on the bottom, this is also going to go to infinity. This is the indeterminate form, infinity over infinity. Let's use L'Hopital's rule again. So it's going to be 27e to the 3x over 9e to the 3x. E to the 3x is cancel. So now we're finding the limit as x approaches infinity of 27 over 9 reduces to 3, and this is going to be 3, which is option C. This next question, it's pretty tough. The functions f and h are twice differentiable with h of 2 equal to 4. Now the fact that it's telling you this is twice differentiable, that means that both f and h are continuous. That's important. I'll come back to that in a moment. The function h satisfies this mess right here, where x cannot be equal to 2. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Now that tells us a lot. First of all, here's what this tells us. Since h is continuous, we should be able to use direct substitution into this. So what that means is this here implies that the limit as h approaches 2 of h of x has to equal 4. That's super important. It's implied in this. It is not explicitly said. And that's one of the keys to this problem. Something else, it says this limit can be evaluated using L'Hopital's rule. Well, that must mean the top and the bottom have to both either go to infinity or they both go to 0. If you look, if we put a 2 into the top, we're going to get 0. So there's a couple things that this is implying here. This implies that the limit as x approaches 2 of the numerator, which is x squared minus 4, that has to equal 0. That's not so important, but this other thing that it implies is the limit as x approaches 2 that the denominator is equal to 0. Super important. In fact, we cannot do this problem without knowing that. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show your work that leads to your answer. Well, I'm going to first focus on this right here. I'm going to use this to figure out what f of 2 is. Since f is differentiable, well, f and h both, then f and h are continuous, which we've already said once. So since it's continuous, that means that this limit should be able to be evaluated by direct substitution. So the conclusion we can draw from that is 1 minus f of 2 cubed should equal 0. And if we were to solve this for f of 2, which is what one of the questions ask us to do, cube root both sides, we're going to get f of 2 is equal to 1. So we got one answer down. Second answer, what is f prime of 2? Well, if we go back and look at the limit, the reason I need to use the limit is because if I can use L'Hopital's rule, I can somehow get an f prime into this problem. If I can get an f prime into this problem, then I can hopefully figure out what f prime of 2 is. So we've already determined L'Hopital's rule can be used for this because we're told that in the instructions. So this should be equal to, this is using L'Hopital, should be equal to the limit as x approaches 2 of the derivative of the top over the derivative of the bottom. Now, the derivative of the top is pretty simple. The bottom, the derivative of 1 is 0. This here is going to be a chain. Take the 3 and we put it on the outside. Inside stays the same, so that would be 3 times f of x, subtract 1 from the exponent. Then we multiply this by the derivative of the inside. Now we got an f prime into the problem. Now, once again, this is a really hard problem, by the way. I'm hoping a harder problem that you will ever see on the AP Calculus test. If this was on the AP Calculus test, this is what separates a 4 from a 5. We're told up here that h of 2 was equal to 4, and I told you that that's implying that the limit of h of x as x approaches 2 is 4. Well, this is h of x. So this limit here should be equal to 4, which means the right side of this problem should be equal to 4. Just rewriting it so we can see this all in one sentence here. Let's evaluate the limit on the right. So in the top, we're going to have 2 times 2, which is 4. On the bottom, we're going to have 3 times f of 2 squared times f prime of 2. On the left, we have 4. What's f of 2? Well, we said that was 1. What's f prime of 2? That's what we're trying to figure out. So this is going to be 4 equals 4 over 3 times 1 squared times f prime of 2. 1 squared is 1, 3 times 1 is 3. So we can multiply both sides by the reciprocal of 4/3. So that would be 3/4 times 4 is 1 over f prime of 2. So 3 is 1 over f prime of 2. If we multiply both sides by f prime of 2, we're going to get that f prime of 2 is equal to 1/3. Make sure we answered both questions. Find f prime. Find f of 2, we did. Find f prime of 2, we also did. So that concludes this problem, and I guess I could have actually put this down here. I had a man-made separation. One last thing, a word of caution. L'Hopital's rule was not the quotient rule. Each of these cases were limits. This is asking us to find this derivative. This derivative would have to use the chain rule. It would be sine of 6x prime over the denominator, or times the denominator, minus the numerator times the derivative of the denominator over the denominator squared. I'm not going to finish that. I just want to make sure that we understand that L'Hopital's rule does not replace the quotient rule. These are applying to different things.